Welcome back, everyone. My name is Daniel Sills, a Master's Electrical Engineering student at the University of Louisville, and you are watching Video Check-In 3 for the Applied Robotics course. In this course, we are attempting to build a submersible robot capable of autonomously completing a variety of tasks. The first one that we are interested in is simply submerging the robot and bringing it back to the surface intact and hopefully not full of water. So in this week's agenda, I'll be covering a parts issue that I've run into, some design updates, including the camera dome, pump hosing, and internal chassis design ideas. And then finally finishing off with the electronics issue that I've now been talking about for it feels like forever. So starting with the parts issue, I have misordered some PVC end caps and 45-degree angle components. These are not hypercritical to me continuing to work at the moment, so I am trying to wait as long as possible just to make sure that there aren't other things that I could do with the budget. So for this class, we were given a $200 budget. I am down to the last $50 in order to get me to the point that I am. And so I'm waiting to do more work specifically on the electronics side as well as the design side to see if there's anything that I could do to maybe not have to order some of the components, or at least get really specific as to the components that I need to get so that I can minimize that cost. And so moving on to some of those design ideas that I discussed, I think the dome is going to be a combination of these two pieces that you see on the left. This is a standardized security camera dome, and then this is a 4-inch to 3-inch PVC bushing is what it is described. So this would fit inside of the pipe, and then this is a 3-inch size on the inside here, and so that would give me roughly a 1/2 inch on this back side in order to mount this dome. And this is roughly the appropriate size. It is 10 centimeters wide, which puts it at like 3.97 inches, something along those lines. So could potentially work. It's another one of those things of like, I want to get it really nailed down before I just order because I'm really tight on the budget right now. And so that brings us to the pump hosing. This is something I will be ordering relatively soon. The hose and these barbs. And so these are screwed through a bulkhead in the diagram on the left. And so in my case, this will be PVC end caps featured at the end of the ballast tanks and the pump motor housings. And so these will help to seal these components. And then this image kind of shows that I'd like to incorporate some hosing on the inside of the ballast tank. And so that allows this hosing to free float within the robot. And so hopefully it will always be at the lowest point in the ballast tank, just like where the water will be. And so that'll limit the amount of time that we're dry running the pumps, because that can be a bad thing. And then the final design idea that I wanted to discuss was last week I was printing this internal chassis component that you see here. It came out a little small, so I'm going to have to adjust the tolerances. It's not bad. It's not like it can twist around or really causes too many issues. So it's definitely, that size is definitely something that I may consider coming back to. The issue is I need the friction of these components to be the main thing holding them into place. I don't really want to glue them because I do want to be able to take them in and out of the body of the robot. I've also started kind of conceptualizing what some of the components would look like. This is kind of what I have in my head as to like a modification that I might add on to this in order to mount the camera. The camera has 4 bolts on the back that are used for attaching the IR emitters to either side of the camera. And so I think those bolts could be reused for adhering it to a mounting plate. Otherwise, I might target some kind of assembly that would have like a ring that the lens would slide into. I need to do a little bit more research on the camera specifically and look into what mounting options it kind of advertises that it has. Other things would be the Raspberry Pi, which is fairly simple, just getting standoffs. A lot of the components being hats and Raspberry Pi and the Arduino that I'm looking at share a lot of the layouts between all of the mounting posts, and so it should be fairly easy to just either add a post or some kind of hole or something to put posts in, and then be able to stack up from there. All right, moving on to electronics, the final part of our presentation this week. So I've started working with my Arduino. I say Arduino, this is a Atmel ATmega 328P breakout and test board. The 328 is the same chip as is on the Arduino, so technically this is an Arduino. This just doesn't have some of the creature comforts. As you can see, I'm having to solder mounting pins onto it in order to use it with actually anything. And so on the right, we have a little GIF showcasing how multi-channel PPM works. I discussed last time that I didn't really understand how this worked, and so you can see that really it's the gap between the PPM channels that allows you to have multi-channel configuration. So I do hope to be able to use multi-channel communication in order to control the two oh yeah, that's actually a funny portion of this video. Is I was doing all of that soldering on top of a box, which I did not realize at first had the battery in it that I was using last time. So that was not great and not super smart of me. But so I hope to use the multi-channel configuration of the PPM signal in order to control the two ESCs that I have. And so finally, going back to those potential solutions, I'm still running into issues. I ran into some issues on the Arduino. I think there's a chance that there could be an issue with my board. I'm going to get an actual Arduino this week. I'm going to borrow one from the lab, and then I have a personal one with my parents. So I can get that before the end of the project, but in order to speed up that timeline, I'm going to borrow one from the lab. And then hopefully just working with an actual Arduino should save me some headaches that the Atmel board was giving me. And then I'm still not sold on this PWM to PPN converter. I just don't, I don't think it's going to give me enough benefits for the additional, it's just not speaking to me. That's what I'm going to roll with. All right, so future work, I'm really trying to get these pumps running. And so this week, I'm going to borrow that Arduino like I talked about, and I'm going to start working with the Arduino library. I have found multiple references of Arduino libraries that can either read or encode PPM signals. And so I'm trying to kind of weigh and balance. I need to get one of them working, and then I can start thinking about which one works better, which one works worse. There's one of them that advertises that it uses interrupts for its pulse modulation, and then another one that advertises that it uses the clock, so it'll be interesting to compare and contrast those. I need to order some final build hardware for the ballast tanks and pumps, and then a big thing this week is I want to get into CAD design. If I can get a good mock-up of the CAD design fully fleshed out, the entire assembly, then I would like to be able to pull that over into MATLAB so that I can start working in the robot simulation environment. All right, I'm almost at my 10 minutes for this week. Sorry it was a little boring. I'll see you next week.